Okay, so here we learn how to find the slope of a line, and still this is another discussion topic in 2.4. So here let's look at example number 1. We would like to find the slope. Find the slope of the line passing through the points 1, 2, and the second point is -5, -1. Okay, so here I have 2 points. Each point here is expressed as a pair of x and y value. So here's one point at location 1, 2. Here's another point at location -5, -1. So once again, these are the points expressed as pairs of x and y values. So now the idea to show you a quick visual display of what the points are and the lines going through the 2 points. Here's the graph for it, and this is basically what's happening right there. So those are the points, -5, -1, and here's 1, 2 right there. So here we have a line passing through the 2 points, and you can see I put the 2 points on the appropriate locations there. And so to find the slope passing through this line, remember, as let's recall that the slope formula, slope is always indicated by a lowercase letter m. So slope equals y2 minus y1, take the difference and divide it by x2 minus x1. And so you have 2 points here. The first, you can call the first point here x1, y1, and the second point is x2, y2. It doesn't matter, it's your own preference. So here you can call this point x1, y1, and here you can call this point x2, y2. Okay. So now to find the slope, as long as you have written down the formula correctly, then the slope formula can be determined by, once again, y2 minus y1. So keep track of your signs once again. So I have -1 minus 2, because -1 is my y2, subtract 2, which is my y1, and all over. And here I have -5 minus 1. And so what I have here is going to be -3 divided by -6. And so in the end, after you reduce the fractions, including reducing the signs, the fraction turns out to be 1/2. And so my slope here is 1/2. Meaning, so my slope is 1/2. So meaning, if you look back into the graph, meaning this line here rising from the left to the right, the line is rising in the ratio of it rises. You can see that every single point it rises 1 units in every 2 run units. So the graph rises 1 units in every 2 run units, and run units is always the distance the running to the right hand side. And so once again, if you check at these 2 points, you can see that it rises 1 units over 2 run units. And so that's the ratio. So that's the slope being 1/2. Okay. So looking into example number 2, we can try a similar example again. And the point is to get comfortable with using the slope formula to calculate the slope of any 2 lines. So in my example 2, once again, we want to find the slope of the line passing through this time I'm having points -2 and 3, and the second point is 1 comma -1. And once again, at this point, it's all your preference to either choose the first pair here is x1, y1, or the second pair here to be the x1, y1. But just make sure that the other points, make sure that once you have labeled one pair as x1, y1, the other pair has to be x2, y2. So now, once again, as a quick visual display of the situations, here are the 2 points. And what I have is the first point is -2 comma 3, and the second point is 1 comma -1. So here I have a visual display of the 2 points, and here's my line passing through the 2 points. And so now we want to find the slope of this line once again. And so the slope of the line, once again, the formula to find the slope is always y2 minus y1 divided by x2 minus x1. And so here what I have here is, in this problem, I'm going to use this point, the second point here, the second pair to be x2, y2, and here's my x1, y1. So in my slope formula, the problem is going to become -1 minus 3 divided by, and I have 1 for x2 minus, and make sure you keep track of your sign, -2 for x1. And so here my formula my setup would become -4 on the numerator of the fractions divided by +3. And so now my overall slope after reduce is going to be -4/3. So that is my slope. And so now to make it consistent, once again, if you check back into the graph that I have showed earlier, so the meaning of this slope equals -4/3 is that this line is, now by the way, the negative sign in the slope is indicating that the line is falling from the left to the right. So if you're looking at this line right here and checking it out from the left hand side to the right hand side, you can see that the line here is falling 4 units. So if you move from the first point to the second point, the line is dropping down 4 square units. 1, 2, 3, 4. The line is dropping 4 square units per every 3 run units. And so that's why we have the slope equals -4/3. So once again, keep in mind when you run into a negative slope, we're talking about a line that's falling from the left to the right.